III in support of the Gemini missions. An addition wrapped around the east, north, and most of the west and south sides of the MCC. New areas included space for flight control briefings, data analysis, and room for a new Gemini spacecraft trainer. The old trend charts on either side of the world map were replaced by rear projection screens. The world map displayed new tracking stations, and one clock above the map changed to estimated liftoff time. A desk for a public affairs officer was also added, along with a pair of consoles on the left side of the room facing inward for the support control coordinator and the display coordinator. After the conclusion of Gus Grissom and John Young's flight of Gemini 3 in March 1965, NASA transferred mission control to Houston, Texas, where it still resides today. After mission control functions were relocated to Houston, Texas, the Mercury Control Center provided backup for the initial launch and the trajectory for the remaining Gemini missions. In 1967, the MCC became a tour stop for guests visiting NASA's Kennedy Space Center Visitor Complex. A bus tour provided the public an opportunity to look through the glass windows of the viewing room and see where the first chapters of American space history were written. It was a popular attraction from 1967 through 1995. In the late 90s, the building began to show signs of aging. In an effort to preserve what remained inside the deteriorating structure, NASA removed the artifacts inside. Later, a plan was developed to create an authentic MCC flight control room exhibit at the KSC Visitor Complex.
The opportunity for relocating this amazing room full of history was to offer it to many, many more people. Accessibility to the actual facility was becoming more and more challenging, and it allowed for the consoles throughout the room to be displayed and preserved. Had they been left in the building all those years, they would be in terrible condition right now.
The exhibit is inside an 8,500 square foot building dedicated to early space exploration.
One piece at a time, we carefully removed it, brought it over. So what you see here is a duplication of the actual MCC, the Mission Control Center, with the screens, the consoles, the flooring, the finishes, and of course the tracking board. The consoles themselves, though, are completely authentic. The tracking map is completely authentic.
Guests get a memorable and authentic experience.
I think it's an amazing opportunity for our guests to look through the glass and step back in time and honor the heroic first years of our space program.
The MCC was designated by the National Park Service as a contributing structure to a National Historic Landmark District in 1984. The district consists of 7 other contributing properties: Launch Complexes 5, 6, 13, 14, 19, 26, and 34. NASA determined the Mercury Control Center was no longer needed for NASA missions and had deteriorated beyond repair. Final artifact preservation efforts began in 2009. The Mercury Control Center controlled the flights of 3 vehicles from 3 launch pads during its years of service. In March 2010, heavy equipment operated by NASA contractors leveled the concrete block and metal building.
You know, it's a transition, but we have to be energy efficient. We have to prepare for the future. We've got to prepare for going beyond low Earth orbit and doing bigger and better things. And this is all part of the process as we grow and change here at the Kennedy Space Center. We will never forget our heritage. It's crucial to us. History is important.
Below thousands of meters of ice in Antarctica lie hundreds of meltwater lakes where the Antarctic ice sheet meets the continent's bedrock. Until pretty recently, we thought that these lakes sat quietly, isolated in pockets under the ice. But in 2007, laser measurements of the ice surface from NASA's IceSat satellite were used to infer what was happening far below, and a much more interesting picture was revealed. By watching local areas of the surface of the massive ice sheet rise and fall due to fluctuations in the lake water levels below, we learned that vast hydrologic systems like rivers connect many of these lakes, and that some actively fill and drain all the time. Thanks to the more advanced laser technology on NASA's IceSat-2 satellite, in a region very near a pair of larger lakes measured in 2007, 2 more of these lakes have just been found. A new study shows that they are currently experiencing a draining period. The finding also gives us the most detailed picture yet of how the boundaries of lakes can change over time. Areas seen here in blue show that the surface of the ice is getting lower, which indicates that the lakes below are draining. Understanding how much water is flowing under the ice sheet and how quickly it can drain to the sea helps give us a better picture of not only how quickly the Antarctic ice sheet will change due to a warming climate, but also how Antarctic melt will affect both global ocean currents and sea level rise.
STEM fans, are you ready? Let's hear it for the world-class NASA STEM Stars team. From NASA centers across the country, we present Dr. Hashima Hassan.
Hello and welcome to this week's NASA STEM Stars. Each week we connect with subject matter experts that work at NASA and learn about their STEM career and their education and personal interests. At the end of today's episode, I will challenge you to complete your own mission and share your work with us. I'm Jen Hudgens and I'm coming to you from NASA's Kennedy Space Center. Today's mission plan will be to meet our guest and explore her career. I want to encourage you to ask your questions in the chat box to be answered by our guest. So let's get started. Today's guest is Dr. Hashima Hassan, and she comes to us from NASA headquarters in Washington, D.C. Welcome, Dr. Hassan. Thanks for joining us today.
Hello, Jen. Thank you for inviting me.
I'm so excited for you to share your work with the Webb Telescope and tell us a little bit more about yourself. So let's just dive right in. Why don't you tell us more personally about yourself and what you enjoy doing?
Well, I'm a program scientist at NASA headquarters, and in my time there, I've managed more than a dozen missions. But these days, one of the missions, most exciting one I'm working on is the Webb Space Telescope. And in my private time, my hobbies are reading, traveling, and cooking. And in these COVID days, I've experimented with a lot of Indian spices and come up with new recipes. And I love exploring new places, meeting new people. And one of the most memorable journeys I did was a train journey across the United States from San Diego and the West Coast of California to Washington, D.C. And my best activities are playing with my grandchildren.
Wow, I bet that was a beautiful trip across the country.
Yeah, it was fascinating, totally fascinating.
Can you tell us a little bit about how you became interested in astronomy, maybe when you were younger?
Yeah, sure. So if you could go to my first slide, I grew up in India at a time when the Indian skies were dark and clear, with no light pollution or industrial pollution. And there were times that we could even see the Milky Way. And I used to sleep out at night in the hot summer nights and stare at the cloud, stare at the sky, at the stars and moon. And my love with space started when the first space satellite, Sputnik, was launched in 1957. And my grandmother got the whole family, right down to my 2-year-old sister, to stand in the backyard of our home in Lucknow and watch Sputnik go past like a moving star in the skies of Lucknow. And just to give you an idea where Lucknow is, I have a map of India on the left, and Lucknow is ringed with red. And there are two more cities I'll mention as we go along. One is Aligarh, which is about 200 miles northwest of Lucknow, and then two on the west coast, Mumbai and Pune. So if you could go to the next slide. Then on the picture on the left is that of my elementary school, Loreto Convent Girls School, which was operated by Roman Catholic Irish nuns who didn't believe in teaching science to the girls except for botany. But I was very fortunate that when I was in the 9th grade, we got a new headmistress. And this nun had just come back from the United States with this revolutionary idea to teach science to the girls. And so my science education started. I went for undergraduate to Lucknow University. I wanted to do astronomy, but my sisters and I were not allowed out of the house unescorted, so there was no question of going for observation that night. So I graduated with what was called pure sciences, physics, chemistry, and math, and then I went on for my postgraduate degree in nuclear physics to Aligarh Muslim University. And from there, I won a scholarship to the University of Oxford. And on the right-hand side, you'll see my college, Lady Margaret Hall, and I got a doctorate in theoretical nuclear physics.
I can say those buildings are gorgeous. I love looking at those pictures. So how did you get from Oxford? Where did you go after Oxford? Because clearly you're working at Washington, D.C. now. So tell me a little bit about your path from India and England all the way to America.
Okay, so from Oxford, I started what I thought would be a traditional academic career, and I went for a postdoc to Tata Institute of Fundamental Research in Bombay, which is the building on the top left. From there, I got a faculty position in the physics department at the University of Pune, which is the building on the right. And that is a historical building. It used to be the summer residence of the governor of Bombay, and it was given to Pune University after independence. And while I was in Pune, I got married, and I followed my new husband across the Atlantic to the United States. And you see on the left-hand side, he was on the lower left-hand side, he was at that time in North Carolina. So I got a tutor position at Duke University in Durham, North Carolina. And while there, I applied for a National Research Council fellowship to the US EPA to study air pollution in Denver, Colorado. And then I had my first baby, and that's another story for another time. And then we crossed the Atlantic again. And so if you could go to the next slide, you'll see that on the upper left-hand side corner is the Bhabha Atomic Research Center, because I was again in Bombay, so I came back to nuclear physics. And then 1985 was a big change. We came back to the US, and this time I had two toddler boys. If you see the picture on the right-hand side, it was a real challenge raising these two little ones. As well as trying to do a full-time job. But I did get a full-time job at Space Telescope Science Institute in Baltimore to develop the simulation software for the Hubble Space Telescope, which was to be launched soon, and its science instruments. And
So we've had a couple questions come in. Can we ask what place was your favorite? So of all of those places that you just told us about, did you have a favorite?
Well, of course, Lucknow University, I mean, Lucknow is my hometown, so that would always be my favorite, but I loved Pune. It was just, or it's called Pune now, it was just a wonderful place to be in.
Another question, what were the biggest space accomplishments during your time studying? And how do they compare to what Webb will do? So we can talk about Webb in a minute, but as far as your studying time and your early career, did you have any big space accomplishments?
Yeah, in my early career, I don't think any of these space telescopes and astronomy had been launched till then, because my early career started in 1976, which was a long time ago, long before the Hubble or any of them. So I would say not till I joined Space Telescope Science Institute.
So after the next slide, you actually address some work that you did on Hubble. So maybe we can share that next slide and you can talk to this one.
Yeah, so as I said, I developed the software for the optics of the Hubble, and I didn't realize how important it would be after Hubble was launched, because we found an optical problem with the Hubble. And so I was responsible for keeping the Hubble in focus till we could analyze all the images and design a fix. So I was appointed the telescope scientist, and for the 3 years when the first servicing mission happened in '93, and the fix was installed by the astronauts. And while there, I was also given research time. So I was able to do research in astronomy, and I published my first paper as a research astronomer in the Astrophysical Journal. And there I finally achieved my dream of being a research astronomer.
And I saw you had a small picture of Hubble there, in case no one was familiar with what Hubble looks like. And we'll talk about the comparisons of Hubble and Webb in a minute. But can you tell us a little bit about how you became a citizen of the United States and then your journey to NASA from there?
Yeah, so we went through the usual process of applying for citizenship. We had to, be in residence for 5 years before you could apply. And so I got my citizenship in 1993. And in this picture you see on the left, I'm in my office at Space Telescope Science Institute, and my colleagues gave me a surprise celebration. They all stormed in with, all typical, as you can see over there, hot dogs and a Chevrolet car and a baseball and red balloons, and complete with a photographer. So, and it was an amazing experience. And then once I was a citizen, I felt that I can now start serving the US taxpayer, and I applied for a visiting scientist, senior scientist position at NASA headquarters, which I joined in 1994.
Okay, we have just a few more questions here. Were you interested in physics before the start of your career, or when you started it? And do you think that becoming a scientist needs, well, I guess, intelligence or the skills maybe that are necessary if you want to become a physicist or scientist?
Yeah, so I wouldn't say I was, I really didn't know so much of, difference between physics and chemistry till I actually started doing it. But I found physics to be the most challenging of the 3 major subjects we did. I loved all of them, but I found physics the most challenging. And I just felt I had to do physics to try and understand what lies at the basis of everything in the universe. And so that's how I went into physics. And I think, first of all, most importantly, you need to have the passion and the curiosity to be a scientist. And if you have that, it may take you a little, it might require some people to work harder to get at it, but everyone can really be a scientist in their own way, because you're basically trying to understand how the universe works.
I think I'm in total agreement. Curiosity and the pursuit for answers.
Exactly.
So let's jump in and talk about some of your work with headquarters at NASA. What projects were you involved in?
Yeah, as I mentioned earlier, I was involved in more than a dozen projects, all of which I can't mention here. So I'm just going to mention three. So you see on the left-hand side, you've seen this picture a couple of times more in this presentation. I'm standing in front of the actual mirror of the Webb Space Telescope, which is inside the clean room at Goddard Space Flight Center when it was being put together over here in Maryland. And then in the middle, I'm in front of the Keck Observatory in Mauna Kea, Hawaii. It's a ground-based observatory, but NASA has a 1/6 partnership because with this, and I'm responsible for that because there are some ground-based observations need to be done to support our for strategic support of our science with our space telescopes. And then on the right-hand side at the bottom is an airborne observatory for infrared astronomy, which is in which we have a telescope which was provided by the German Space Agency, with whom we have a partnership inside a 747. And on the top right-hand corner, I'm inside the observatory in the plane with a group of teachers who we call the Airborne Astronomy Ambassadors. And I'm also responsible for education and public outreach for astronomy. So you're seeing me here with the teachers. So there are a lot of different things we do as program scientists at headquarters.
We've had a student ask what project that you worked on or that you can discuss do you think had the greatest impact so far?
I would say definitely the Hubble Space Telescope. It's now been going on for 30 years, and it's made great discoveries of things we didn't even know of. And excuse me. And some of the research done by Hubble led to a Nobel Prize on dark energy, which Adam Rees was one of the astronomers who got the prize.
One of the students will also want to know what were some of the biggest challenges with Hubble. So, I know when we were showing your papers, you had talked about the inability for Hubble to focus. So do you think that was your biggest challenge?
So that was the earliest challenge, was the optics problem, which we fixed with the servicing missions. But then it's got very old technology, and the instruments we had to change them out. So we've had 5 servicing missions so far, where we've changed out instruments, where we've fixed problems on Hubble, and so it's still going strong. It's 30 years old.
So your newest project is with the James Webb Space Telescope. So is the Webb Telescope intended on taking over Hubble's work, or is it going to be in conjunction with what Hubble does? Let's talk a little bit about the Webb Telescope.
Yes, so the Webb is considered as a successor of Hubble. As you'll see, as a